What does the graph tell us? It tells us that electrons are made of two elementary particles, which I have named half-licks. It tells us that protons and neutrons are made up of over 3,600 half-licks. It tells us that matter and energy are distinct and disparate, and are not transmutable one to the other. It tells us that Einstein's equation is not an evaluation of how much energy is converted from a given quantity of matter. E equals mc squared tells us how much energy is bound up with matter. It tells us there's a lot more energy in the universe than physics and cosmology ever dreamed of. And it tells us what the universe looked like the instant before the Big Bang, when matter and energy were separated. In a nuclear event, like an atomic explosion, all the beta particles that are released were always there. Each nucleon possesses enough half-licks to produce more than 1,800 electrons or beta particles. That means that all of the matter that was originally there in the form of a nucleon is still there. It has only expanded. So matter was never converted to energy. Therefore, almost all of the energy released was also there to begin with. By adding a critical amount of energy, the nucleon just expanded. This is analogous to adding energy to water to produce vapor. In both cases, the extra added energy produces a change of state. It's just that simple. Nucleons are therefore a very condensed form of matter and energy. What does it all mean? Well, we first have to ask ourselves, what do we know about matter and energy? We know that matter is attracted to matter, because we can walk around on this planet without fear of suddenly flying off into outer space. We know that energy is attracted to matter, because matter is constantly absorbing energy, as when the planet absorbs energy from the sun, or when we absorb energy by sunbathing, one of the more pleasurable examples. And we know that energy repels itself, which we observe with any incandescent light source, where photons spread out as fast and as much as possible in order to get away from each other. So, matter is attracted to matter, energy is attracted to matter, and energy is repelled by itself. This means that every half-lick is going to attract photons, and that those photons are going to stick to it. So the photons will create an energy field around the half-lick, which will extend to some limit, at which point the repulsive force between photons will be greater than the attractive force between the half-lick and the photon, and the particle will reach the saturation point. This also means that all particles and assemblies of matter will also be surrounded by an energy envelope. Because fractional charges are rare, we know that although a half-lick may reach its saturation point and not be able to hold any more energy in its envelope, it still has an attraction for more energy and more matter. And if it encounters another half-lick, they will merge to form an electron. Because we know that electrons are very stable particles, we know that the matter nucleus of an electron, being twice that of a half-lick, is able to hold an energy envelope that is sufficiently large to repel all other like-sized or smaller particles. By the same token, we know that a proton, because it exhibits a similar stability to that of the electron, must also be a saturated state of both matter and energy. Although it is unable to hold more matter or more energy, it still has its mass attraction for other nucleons, electrons, half-licks, and photons. So when an electron enters the gravitational field of a proton, it is attracted to it, and in fact, in most cases, collides and melds with the proton. But because the proton is in a saturated state, the matter nucleus of the proton is unable to hold one more extra electron, and as soon as one electron collides with the proton, another is ejected. This gives the impression that an electron orbits a proton, but in fact, the electron being observed is never the same one twice. Every time one goes in, another comes out. It is only at the center of multinucleon atoms that the matter density becomes large enough to allow some extra electrons and half-licks to be captured by internal protons, which then form neutrons. But as soon as a neutron is dislodged from an atom and is no longer associated with the extra mass, it readily gives up the extra and decays back to a proton. Matter and energy are distinct and disparate. In the beginning, matter and energy were separate. It was when matter and energy first collided that our universe was created in a Big Bang. And it is small chunks of the original mass of cold matter that were ejected in the initial explosion but never were able to capture enough energy to expand that are now observed to be black holes. In the light of this fact, it should be blatantly obvious that the LHC could never produce a black hole. We do not possess any technology that is able to remove or separate all of the energy from any amount of matter, and certainly not in a high-energy environment like that exists inside the Large Hadron Collider. It is just not even remotely possible. The true nature of subatomic structure is simple, beautiful, and elegant.